This is a demo video for the DIY pulse oximeter. So to set it up, that's pretty simple. All you have to do is plug in this casing. This contains the sensor and the Arduino and the wiring inside of it, and plug the Arduino in to any laptop, and then pull up the user interface onto your laptop. It's an HTML file. And then once it's all connected, the sensor light should be red, and that indicates that it's on. And to connect it, all you have to do is click the connect button, click on the Arduino pairing, and then press connect. So it should turn on, and then when any person comes in, like a kid or parent, kind of just instruct them to place one of their fingers on top of the sensor, fully covering up the sensor. And they can rest their hand on the casing kind of like a mouse, but just make sure they're not pressing too hard or too lightly. And then to start kind of the user interface, all you have to do is click the spacebar. This starts and stops it. So typically what I would do is once they place their finger on there, I would then hit the spacebar and it would start. So almost immediately you'll see the waves. It's a PPG wave. However, in case they ask, it's not their actual wave. This is just like a representative image. The SpO2 concentration below that, however, is their actual SpO2. It takes a few seconds for the sensor to calibrate. And so yeah, this is essentially kind of what you showed them. Demo-wise, the finger would be on the sensor, and then the SpO2 will update kind of as it goes on. And so kind of the science behind it, first to kind of start off from a more biological point of view, SpO2 is just kind of like the blood oxygen concentration, and healthy humans have about 95 to 100% O2 saturation. So if most people who do come up to visit, they're going to have a saturation level in that rate. If it is lower than that, considerably lower, maybe anything below, in the 80s or below, that likely means that their finger is not placed correctly, or there's just an error with the sensor. If their oxygen saturation is really that low, they would, be struggling to breathe. They'd be dizzy, drowsy, and so you'd be able to tell. And then, so the way the sensor itself works, it's shining two lights, an infrared light and a red light, and it's basically seeing how much hemoglobin, which is a protein in your blood, or how much of that protein is bound to oxygen. The infrared light is able to be absorbed by the hemoglobin that is bound to oxygen, and then the hemoglobin without oxygen absorbs the red light. So essentially what the code is doing with the sensor, and then it's getting processed, it's examining a ratio of these absorbances. It's calculating kind of the values, and it factors in kind of how much skin, bone, etc. it has to go through, and then it's able to then output an SpO2 value. It is sometimes a little less accurate in darker skin tones, just because of melanin, and then possibly also, that's one variation factor. You need a deeper light. This is kind of just a DIY mock thing, but essentially this is a glorified version of kind of all the pulse oximeters, the clip-on devices you see in a clinic that measure both your SpO2 and your heart rate. Some of the next steps for this project would be to add a heart rate calculation in this as well. In the past it hasn't been as accurate, but going for accuracy, average heart rate is between 60 to 100 beats per minute. So yeah, thank you.